Hello students, let me introduce you to the chapter probability. In this chapter, we shall look into the introduction, random experiments, event and axiomatic approach to probability. Let us start with the introduction. It may rain today. Rajesh is quite sure to top his class. It is highly unlikely that Abhishek will marry Karina. All these statements indicate uncertainties in everyday life. Probability is a measure of uncertainty. The probability theory developed as a result of studies of games of chance or gambling. Suppose you pay rupees 2 to draw a card out of a pack of 52 cards. If you draw an ace, you get rupees 20, otherwise you get nothing. Should you play such a game? Does it give a fair chance of winning, or are you going to lose in the long run? Search for mathematical answers to these type of questions led to the development of the modern theory of probability. Italian mathematician Jerome Cardin, French mathematicians Pascal and Pierre de Fermat, and Swiss mathematician James Bernoulli were the pioneers in these studies. In earlier classes, we studied about the concept of probability as a measure of uncertainty of various phenomena. We have obtained the probability of getting an even number in throwing a die as 3 upon 6, that is 1 upon 2. Here the total possible outcomes are 1, 2, 3, 4, 5 and 6, that is 6 in number. The outcomes in favor of the event of getting an even number are 2, 4 and 6, that is 3 in number. In general, to obtain the probability of an event, we find the ratio of the number of outcomes favorable to the event to the total number of equally likely outcomes. This theory of probability is known as classical theory of probability. In class 9, we learnt to find the probability on the basis of observations and collected data. This is called statistical approach of probability. Both the theories here have some serious difficulties. For instance, these theories cannot be applied to the activities or experiments which have infinite number of outcomes. In classical theory, we assume all the outcomes to be equally likely. Recall that the outcomes are called equally likely when we have no reason to believe that one is more likely to occur than the other. Thus, to define probability, we used equally likely or equally probable outcomes. This is logically not a correct definition. Thus, another theory of probability was developed by A. N. Kolmogorov, a Russian mathematician, in 1933. He laid down some axioms to interpret probability in his book Foundation of Probability. In this chapter, we will study about this approach called axiomatic approach of probability. To understand this approach, we must know about few basic terms like random experiment, sample space, events, etc. Let us learn about these all in what follows next. Random experiments. An experiment, that is an operation or action resulting in a well defined outcome, is called an experiment. The process of conducting experiment is called trial. whereas the outcome is called event. Sometimes the result, that is outcome, is unique. For example, given any triangle, we can definitely say that the sum of the measures of the angles is 180 degrees. Sometimes the outcome may not be unique. For example, tossing a coin may throw up either heads or tails. Such experiments are called probabilistic or random. Note that here trial is tossing the coin, event is getting heads or tails. Here we are not sure which one of these results will actually be obtained. Such experiments are called random experiments. If an experiment can result in two or more outcomes, it is called random experiment. Examples are tossing a coin, throwing a die, or throwing a pair of dice. Dice is plural of die. An experiment is called random experiment if it satisfies the following two conditions. First, it has more than one possible outcome. Second, it is not possible to predict the outcome in advance. Now, let us see what you mean by outcomes and sample space. A possible result of a random experiment is called its outcome. Consider the experiment of rolling a die. The outcomes of this experiment are 1, 2, 3, 4, 5 or 6. If we are interested in the number of dots on the upper face of the die, the set of outcomes 1, 2, 3, 4, 5, 6 is called the sample space of the experiment. Thus, the set of all possible outcomes of a random experiment is called the sample space associated with the experiment. Sample space is denoted by the symbol S. Each element of the sample space is called a sample point. In other words, each outcome of the random experiment is also called sample point. Let us now consider some examples. Let us look at this example. Two coins, a 1 rupee coin and a 2 rupee coin are tossed together. Describe the sample space. Here, each coin may come up as head H or tail T. To describe the outcome of two, that is distinguishable coins, we use ordered pairs. We may get head on both coins as H, H, head on first and tail on second H, T, tail on first and head on second as T, H, tail on both coins, that is T, T. Thus, sample space here is S is equal to H, 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 T, T, H and T, T. We may also write S is equal to H, H, T, T, H, T, T for convenience. Let us see another example. Describe the sample space when a coin is tossed 3 times. Here the sample space will be S is equal to H, 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 T, H, T, 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 H, H, T, H, T, H, T, H, T, T, H, T, 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 where H stands for head and T stands for tail. Let us see one more example. A coin is tossed and a die is thrown. In coin, H and T occur, and in die a number from 1 to 6 may occur. List the sample space. Here the sample space formed will be S is equal to H 1, H 2, H 3 H4, H5, H6, comma T1, T2, T3, T4, T5 and T6, where H and T represent head and tail of a coin. Let us take up one more example. A coin is tossed and then a die is rolled only in a case of head is shown on the coin. List the sample space. The sample space S will be equal to H1, H2, H3, H4, H5, H6, where H represents a head of a coin. Now, another example here. Suppose 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective, that is D, or non-defective, that is N. Write the sample space of the experiment. Let D represent defective and N represent non-defective. Then the sample space is S is equal to D D D, comma D D N, comma D N D, comma D N N, comma N D D, comma N D N, comma N N D and N N N. Another example here. A die is thrown repeatedly until a 6 comes up. What is the sample space for this experiment? The sample space is S is equal to 6, comma 1, comma 6, comma 2, comma 6, comma 3, comma 6, comma 4, comma 6, comma 5, comma 6, comma 1, comma 1, comma 6, comma 1, comma 2, comma 6 and so on. Hence, infinite number of possibilities occur. So, students, today we introduced chapter probability. In the next session, we shall study about event, occurrence of event and types of events. Thank you.